Hello and welcome to today's update. We'll be solving challenge number 24. Let's begin. Okay, question 1137, nth the Fibonacci number. So this is seems like it's a version of the Fibonacci number where you can define the next number as the sum of the previous two, where the first t0 is 0, t1 is 1, and here they've just extended that definition to t3 as being the sum of the previous three. Okay, so there's a number of different ways to solve this. There's the iterative way, there's the you can solve it recursively starting from the end or from the actual end of the Fibonacci number, the end that you're requested to solve for. But there's a better way, dynamic programming way, where you can start from 0 and you can build up the Fibonacci number, shifting the arguments for the function that's defining it. So let's try to do that. We'll have a private function called Fibonacci, where that will take the, let's see, -0, -1, and -2, and I'll also take an I. We'll say that if, let's do the new num, or the current num to be equal to the sum of these three, so mz plus m1 plus m2, and then we'll say if I is already equal to n, then return cur num. However, else we will say that the return value should be the same argument, but with the arguments shifted. So the current number, or the fourth number in this sequence, would be the current number. So you can say that m1 becomes the first, m2 becomes the second, cur num becomes the third, and I goes one ahead. And here, and that's pretty much the whole definition. Now, we cannot pass, or we could pass, or modify this function to also support the first three integers. So something like if I is less than, if I is less than or 0, return 0. If I is less than or equal to, I is less than or equal to 2, return 1. If I is less than or equal to 3, return this Fibonacci number. But with these preset to the values that we want. Okay, and actually this should be good enough, and we will not be caring about what these numbers are actually initially. We only care that this is passed incorrectly, and that is wrong. Put 0. Okay, don't mind this modification. I'm actually going to do this here. This is probably the more standard way to go about this anyway, so I don't know what's happening in there, but if n, then we'll just be returning. So what this is saying is that this is just sort of like the starting condition for, or the edge case conditions of where we don't actually need to calculate the tri-banatic sequence. It's just that we're given either 0 or 1 or 2 as the parameter, in which case we can immediately return the value. This would be 3. And this, it's accepted. Sweet. Okay, I want to see if there's better definitions. Quickly. Let's see. I don't want to use LRU cache. Although I see how LRU cache can do the same thing, because the least recently used element is always the last one. So it would be cached. No, still the same. So just more clever ways of structuring the function, but the idea is still the same. Dynamically growing the sequence until you get to the requested nth tri-banatic. Sorry. Anyway, yeah, I think this is a good enough solution. Beats about 75% of the competition. So yeah, thank you for watching. See you later.